The Duge Bridge is a miracle. Look at this view. You are standing 565 meters above the Niju River. To put that in perspective, if you dropped a stone from this railing, you would have enough time to check your phone, look at the scenery, and maybe even subscribe to this channel before it finally hit the water 10 seconds later. But the height isn't the real story. The real story is why every engineer on Earth said this bridge was a suicide mission. They called the geology here unbuildable. They called the winds unpredictable. Today we aren't just looking at a bridge, we are deconstructing a 2026 engineering masterpiece. Welcome to Build Theory. Let's get into the video. To understand the Duge Bridge, you have to look under it. These mountains are karst limestone. Now, in high school geography, that sounds like a boring term. But in civil engineering, it's terrifying. Karst limestone is basically Swiss cheese. Over millions of years, water eats away the rock, creating massive hidden caves, underground rivers, and vertical shafts that don't show up on a standard map. When the survey teams first arrived, they found a nightmare. The spot where the bridge should have been built, the narrowest point, was sitting right on top of a hollow cavern. If they had placed the 269-meter-tall main tower there, the entire structure would have eventually punched through the mountain like a heavy needle through a cardboard box. The engineers had a choice: give up or do something incredibly expensive. They chose the expensive route. They moved the entire site 2 kilometers away. Imagine moving a mountain-sized project because the ground decided to be hollow that day. That is the reality of Guizhou engineering. Once the foundations were set, they met the second boss of this level, the wind. At this altitude, the wind isn't a breeze. It's a constant, 100-mile-per-hour hammer. But it's not the strength of the wind that kills bridges. It's the rhythm. Have you ever heard of vortex shedding? When wind hits a solid object, it creates swirling whirlpools of air behind it. These whirlpools push the bridge up, then down, then up again. If that rhythm matches the bridge's natural bounce, you get the Tacoma Narrows disaster. The bridge begins to twist and dance until the steel snaps like a toothpick. The Duge Bridge engineers solved this with a steel truss deck. Look closely at the video. See those triangles? The bridge isn't a solid wall. It's a cage. The wind literally passes through the road. By letting the enemy in, they neutralize the force. It's the ultimate Aikido move in engineering. Now, why does this matter for us in 2026? Because the same technology that keeps the Duge Bridge from swaying in a Chinese gorge is currently being used to finish the Jeddah Tower in Saudi Arabia. We are moving from horizontal miracles to vertical ones. In Jeddah, they faced the same vortex shedding problem at 1,000 meters high. The tower's tapered shape, changing width as it goes up, is designed to confuse the wind, just like the Duge Bridge's truss deck. We are living in an era where we no longer fight nature, we outsmart it. The Duge Bridge cost over $150 million and took 3 years to build. But the master theory here is simple: precision beats scale. From the millimeter-accurate joining of the 2 bridge halves to the deep caisson foundations in Swiss cheese rock, it proves that impossible is just a word for unfinished math. So, would you drive across it? Personally, I keep my eyes on the road and pray the wind likes me that day. If you've made it this far, you are now part of the 5% who actually understand the why behind the what. Just subscribe our channel to join our team. Our next deep dive on the Jeddah Tower's 2026 completion is going to be even bigger. I'm Built Theory, and I'll see you in the next one.